Bhagyashree Ambore, Assistant Professor, Department of CSE, Cambridge Institute of Technology, Bangalore. Today I'll be teaching two-dimensional arrays. We'll start with two-dimensional arrays. Whenever we have a tabular data, that is data arranged in the form of rows and columns, we are using this two-dimensional array. It is a table of data items of similar data type with two subscripts stored continuously in a memory under a single name. Like previously, we have in a previous session, we have studied about one-dimensional array. Similarly, two-dimensional array makes use of two subscript. One-dimensional makes use of one subscript. Here it is making use of two subscript. Now we'll see how to declare, what is the syntax to declare two-dimensional arrays. It needs a data type. It can be any basic data type, name of the array, and row size, how many rows are there, and column size, how many columns are there. Here, the row size is an integer, as well as column sizes also must be an integer positive number. Index row size always starts with 0. The column size always starts with 0. As we have already seen in a one-dimensional array, the subscript always starts with 0 and the maximum size minus 1. Here also these two subscripts will start with 0, so maximum size minus 1. The first index, that is this index, talks about row. The second index talks about column. We'll see one example. I have here a matrix A. You all have studied matrix. So this I have considered one matrix. The name of the matrix is A matrix. Now see what type of data I have stored here. That is integer values I have stored. How many rows are there? 1, 2, 3 rows. How many columns are there? 1, 2, 3, 4. 4 columns. I can do a declaration. All values, all the elements in the matrix are of type integer. Name of the matrix is A. There are 3 rows and 4 columns. Here. Now we'll go with the memory layout. Consider another example. Array name is B. 3 rows, 2 columns. Now, how these will be placed? First value will be placed 0th row, 0th column. Second value will be placed 0th row, first column. Third value will be placed first row, 0th column. Fourth value will be placed first row, first column. The fifth value will be placed in second row for 0th column. And the last value will be placed in second row, first column. What we'll understand from this here is, the compiler starts assigning the values row by row. First it completely finishes this row, then it goes with the second row. Then it completely fills the values, then it goes with the third row. Example, it is continuous allocation, continuous memory allocation. For example, B of 00 is at location 8000. Then next value will be B of 01. That will be stored at location 8002 because it's an integer declaration. The next one is first row, first column. That is first row, that is 0th column. First column is 0th column. Value stored at location 8004. Then first row, first column. First row, first column. Then 8006. Then we have second row, 0th column. Second row, 0th column. 8008. It does it nothing but row by row assigning the values. If its starting address is 8000, every time it increments it by 2 bytes. On 16-bit machine, we'll consider integer occupies 2 bytes. Here also I have considered integer takes 2 bytes. So I have incremented it by 2 every time. Now we'll see number of elements. How many elements are there? Now there is a formula to find out the number of elements. We have a row size into column size. Now I'll consider one example. I want to consider marks of 30 students for 6 subjects. So how many entries are there? How many elements are there? Row size into column size. That is 30 into 6 equals to 180 elements are there. Now we'll try with a small number, that is a float type data type. We have used average 4 rows, 5 columns. 4 students, 5 subjects. I want to take average, or you can consider 4 rows, 5 columns. So how many elements are there in this? 4 into 5. Total 20 elements are there. Clear? Now these 20 elements has to be stored in a memory. How much memory? That memory size we can calculate by using this. Memory size equals to row size into column size into size of data type. Now we'll consider one example. The first one, int marks of 30 rows and 6 columns. We'll see how much size it takes. Row size is 30, column size is 6, size of data type integer is 2. So 30 into 6, 6 3s are 180 into 2, 360. Total it takes 360 bytes of memory. We'll take a float average of 4 rows, 5 columns. First row size is 4, column size is 5 into size of data type float is 4. So 4 into 5 is 20, 20 into 4 is 80. So it takes around 80 bytes of memory. Now I'll consider for character. Character data type takes 1 byte. How many characters are there? Rows are 20, columns are 10. 20 into 10 is 200. Into 1 is equals to 200. It takes 200 bytes of memory. If I'll consider this, the starting address is 8002. It keeps on assigning the values. Place the elements like this. A of 0001 row by row, it fills the values, and how it increments every time by 4 because it is float data type. Now we'll see after declaration how to assign the values inside those locations. You know that how many elements are there, how much memory space it takes. Now how to assign the values inside those locations. That is nothing but initialization of two-dimensional arrays. While declaring itself, I'm giving the initial values to each and every element in the array. Every location in the array, we call it as initialization. Now again, there are two types of initialization. One is at compile time initialization, another one is at runtime initialization. During the compilation process, the compiler assigns the values to each element in the array. Now at the runtime, it asks the user to enter the values. After entering, it scans, it reads, and it assigns to the each location. Now we'll see there are total 5 ways of assigning the values at compile time. We'll start one by one. The first one is full initialization by giving list of values. First one is full initialization by giving list of values. The syntax is type. This is data type, name of the array, row size, column size, and the list of values. How many values you want to give, you just put it in a square bracket, separate them by a comma, and end with a semicolon. Now we'll see the example. Integer A is the name of the array. 3 rows are there, 2 columns are there. So I will enter here how many? 3 into 2, 6. I need 6 values. So I have entered 1, 2, 3, 4, 5, 6. The first value will be assigned in first position, that is A of 0 through 0th column. Second value will be assigned in 0 through first column. Third value will be filled in first row, 0th column. Because I said here 2 columns are there. I said here only 2 columns are there. And I said 3 rows are there, 2 columns are there. 3 rows, 2 columns. This is first row. This is first row, this is second row, and this is third row. It fills the value row by row. Then we'll see full initialization by giving values row by row. In a first case, we have given list of values. Here we'll give row by row. Again, I have considered the same example. Integer A of 3 rows, 2 columns. I said 3 rows. So I have to give here row by row values. Each row has how many values? 2 values, because I said column size is 2. So 1, 2 is the first row values, 3, 4 second row values, 5, 6 third row values. So even though you assign in a row by row way, but values will be assigned in a memory. First 0, 0 position 1, 0, 1, 2 will be assigned. A of 1, 0, 3 will be assigned. A of 1, 1, 4 will be assigned. A of 2, 0, 5 will be assigned. A of 2, 1, 6 will be assigned. That is, this is first row, this is second row, and this is third row. Here, we'll go with the next one. That is full initialization by giving values in a matrix form. In a first case, I gave the values in list. That is continuous values separated by comma I gave in a first method. Second method, I gave the values row by row. Here in a third method, I'm giving values in a matrix form. That is, I said again, same example, 3 rows, 2 columns. Name of the array is A. So here, first row, second row, third row. First column, second column. That is, I said 2 columns, 3 rows. I'm giving in a matrix form. It almost looks like a matrix, but not exactly, but it looks like a matrix. Even though you give values in this form, it is going to assign a memory as first row will be filled with 11 and 21. Second row will be filled with 33, 44. Third row will be filled with 50 and 60. Next, we'll go with partial initialization. What is the meaning of partial? I'll be telling something. I said 6 elements I want, but you have given only few values. What about the remaining values? We'll see with this example. Here I said 3 rows, 2 columns. 3 into 2, total 6. 6 elements are required. But what I have done, I have given only first, second, only 3 values I have given. 1, 2, 3. 3 values I have given. First 2 values will be placed in first row. This 3 will be placed in second row. Remaining rows will be filled with zeros. This is called partial initial. Only partial part of a array I am filling. Rest all will be filled with 0. Next, we'll see initialization without size. In case of one-dimensional array, compiler will count the number of elements what you have given and it will fill. What happens in case of two-dimensional array? Now I have given here int a of blank. Row size I have not given, only I have given a column size. Now I have given here all the values. Now we'll start counting how many elements are there. 1, 2, 3, 4, 5, 6. Total 6 elements are there. And you said how many columns? 2 columns. Compiler uses this formula to calculate the row size. That is, row size equals to total number of elements. Just now we counted it as 6 divided by column size. How many columns are there? 2 columns. 6 divided by 3 it is 6 divided by 2 it is 3. So row size is 3. This matrix is A of 3 rows, 2 columns. So it will assign A of 0, 0 as 1, A of 0, 1 is 1. First row, second row will be filled with 1, 1. Third row will be filled with 1, 1. This way it assigns the value. Make a note that column size is compulsory, mandatory. Without column size, compiler will produce you an error message. So you can write this row size as optional. You can take it as optional, but what is compulsory here? Column size. And total, depending on the total number of elements and the column size, it is calculating the row size. If you skip this, compiler will fail to calculate the row size. If you skip this, again compiler will not be understanding how many rows are there. How many rows are there, then how will it assigns like this? Locations cannot be fixed. How much memory is required? That is also not clear. So compiler will show you an error message. Now we'll see assigning values at runtime. I said there are 2 ways of assigning. First one is compile time, another one is runtime. Compile time, you have understood all 5 methods. Now we'll start with the runtime, how to assign the values at a runtime. Now I have done a declaration int A of 3, 2. That means 3 rows, 2 columns. The assignment will be like this: first row, second row, third row. The values I have not given anything, just assume it is empty. Now I'm asking here, enter 6 elements. How many elements? 6 elements. So how many percentage these are required? Because it's an integer. To read 6 element, I need 1, 2, 3, 4, 5, 6. And first value has to be placed in a position A of 0, 0. Second value, A of 0, 1. Third one, A of 1, 0. Fourth one, A of 1, 1. Fifth one, A of 2, 0. Last one, A of 2, 1. Like this, the values has to be placed by giving their addresses. Now consider here, I have given, it has asked me enter 6 elements. I have given 10, 13, 14, 6, 90 and 23. First, it will scan the first value, 10. It will read it, it will scan, and it will place in the position of A of 0, 0. That is address of A of 0, 0. Second value, 13, it will scan and it will place in the position of A of 0, 1. That is address of A of 0, 1. 13 will be placed here. Similarly, it goes on scanning and placing in its addresses. Now the problem is, if there are only 6 elements, I can use this method. What if row size is 30 and column size is 2? How many elements I have to read? 30 into 2 is 60. Total, I have to read 60 elements. It becomes very tedious to write this 60 percentages and write 60 position addresses. It is very, very, very difficult to specify which location, go to this location address. So it becomes very tedious. We have another concept of reading the same values. Reading the same values in another method. How to make it simpler. Now again, I have made the same declaration, integer, A, 3 rows, 2 columns. Now I'm asking user to enter array elements. I have not told how many elements, simply I have asked user to enter the elements. Now I'll start a for loop. I equals to 0, I is less than how many rows? 3 rows. I plus plus. This for loop is used for rows purpose. Now we'll start another for loop. J equals to 0, j is less than 2. 2 is what? Column size. J plus plus. This loop is used for columns. Now first for loop is used for row purpose. Second loop is used for column purpose. Now I've written first row, first column. I have to fill the value by using the scanf function ampersand A of I, j. I will be 0, j will be 0. So first value will be placed in A of 0, 0. Now only this j loop will be incremented. This uses a nested for loop concept. So inner loop will be executed multiple times, then the outer loop will be executed. In this case, in outer loop will execute for 3 times. In every time the inner loop will execute for 2 times. Total 6 times the inner loop will execute. How? We'll see this example. The same loop I have taken here, the same code what I have written in a previous slide I have taken here. The skeleton almost looks like this. I is 0. First time I value is 0. Then the inner loop works for 2 times. Correct? J equals to 0, j equals to 1. When j equals to, condition fails. Then I will be incremented by 1, I becomes 1. J value will be 0. J equals to 1. Again inner loop works for 2 times. Again j becomes 2, condition fails. I will be incremented by 1, I is now 2. Again j loop will be executed for 2 times. I said the loop, outer loop will execute for 3 times, the inner loop will execute for 6 times. Now we'll see the combination. First value will be placed in 0, 0, position 0, 0, 0 row, 0th column. Second value will be placed in a position 0th row, first column. Now we'll consider this. This value will be placed in a combination of first row, 0th column, first row, first column, second row, 0th column, second row, first column. In this way, the values will be assigned. Now we'll see the tracing of it. In a pass 1, initially I value is 0. 0 is less than 3. 0 is less than 3. Condition is true, right? So it starts with the inner loop. What is inner loop? J loop. J is equals to 0. How many times J has to run? 2 times. So 0 is less than 2. Correct. It reads the value of, that is the code what I have written. Reads A of ij. Reads A of ij. What is the value of A? 0. What is the value of J? 0. I is 0. J is 0. So it reads the value in a first position, A of 0, 0. Then what will be incremented? Only J will be incremented. J now becomes 1. 1 is less than 2. Correct? Yes, it is correct. It reads the value A of ij again. It reads the position. I value is still 0. J value is 1. I value is still 0. J value is 1. Now J becomes 2. It will be incremented here. J becomes 2. 2 is less than 2. 2 is less than 2. Condition fails. It comes out. When it comes out, what it does? It increments the I value. Now I becomes 1. I becomes 1. Now it starts with I equals to 1. I is less than 3. Yes, I is less than 3. Condition is true. Again it increments it starts a J loop. Its I value is 1. Again it starts a J loop. Sorry. Now J value is 0. 0 is less than 2. Yes, it is correct. It reads A of ij. That is, it reads A of ij. That is A of 1, 0. It fills the value in the address of A of 1, 0. Then J will be incremented. J becomes 1. J is equals to 1. 1 is less than 2. Yes, 1 is less than 2. It reads the value A of ij. That is, I value is 1. J value is 1. I'm talking about this 2. I value is 1. J value is 1. Now again, J will be incremented by 1. J becomes 2. Condition fails. Then it will increment the I value. Then it will increment the I value. Then we have I value is 2. 2 is less than 3. Yes, condition is true. J value will be assigned to 0. 0 is less than 2. Condition is true. Again, it reads the value A of ij, that is 2 second row, 0th position, 0th column. So this address will be given. The value will be placed in this address. J will be incremented by 1. J becomes now 1. 1 is less than 2. Yes, it is correct. So it will read the next value in A of ij, that is I value is 2. J value is 1. Now J will be again incremented. J becomes 2. 2 is less than 2. No, condition fails. I will be incremented. I becomes now 3. Now in a fourth pass, I is 3. 3 is less than 3. Correct? No, condition fails. Condition fails. Now, whatever we studied, the passing and all won't be asked in the exam. The main thing you have to learn is how to write a program for matrix or using any two-dimensional arrays. First part of the program is declaration. What all we need for declaration? We need a data type. What is the size of a row? What is the size of a column? I is for looping purpose, J is for looping purpose, and a array, two-dimensional array. A of 10, 10. I have given enough space. How much you want to use, you use. I have given here 100. If it is integer, 200 bytes of memory I am assigned for a two-dimensional array. How much you want to utilize from that 200 bytes, you use it. But this is the declaration for reading one two-dimensional array. This is the row size, this is the column size, this is for row loop, this is for column loop, and this is the two-dimensional array. Now we have a second step is reading the size of a matrix. Now I'll ask the user to enter the row size and the column size. User will enter that I will read it in a variable m, row size, in variable n as a column size. For example, if I have a 2 cross 3 matrix, 2 cross 3 matrix, what is a row? 2. What is a column? 3. So m will become 2, n will become 3. In that way, I will be asking the user to enter the row size and the column size. Now, after understanding what is it, after knowing this, what is a row size and what is a column size, the next step is reading the array elements. How to read the array elements? As I said, one loop for row, one loop for column I have to start. So here I'm starting I loop for row and j loop for column. What is the I initial value? all the subscript will start with 0, so I have to start a loop with 0. What is the row size? Yum I plus plus. What is the column size? N j plus plus. Now I'll read scanf percentage t ampersand a of ij. You don't do anything here. The compiler itself will do this. The looping will take place automatically. The outer loop works for one time. The inner loop works for whatever value of n. I don't know. So it is n times it works. In my case, I have taken it as 3 cross 2. So it works for 2 times. It works for 2 times. Every time when I value changes, it works for 2 times. That is, it has to fill all the values in a row, right? So it will work for 2 times. Now we'll see how to print the array elements. How to print. After assigning the values, we need to print the array elements. Usually we use this two-dimensional array for the matrix purpose in a tabular fashion. Then we are using this 2 for loops, 1/n. Whenever I'll start a new loop, whenever I'll start a new row, I'll start with a new line. Then I'll fill the values in a row. But how I'll fill? I'll leave a tab space between the values. Clear? Now I'll start this. I'll be printing, and the array elements are from beginning. I have to start, right? So I equals to 0. I is less than what is the row size? I plus plus. This is whenever I'll start a new row, I have to start with a new line. So I've used a /n. Now the inner loop works for n times. That is, n value I have taken it as 2 rows. Sorry, 2 columns. So 3 rows, 2 columns. So it starts printing the value. First value is a of ij. 0, 0. Then it will place the value of a of ij. That is a of 0, 0 here. After that, it leaves the tab space. Then the j value will be incremented by 1. 1 is less than, again 2. Yes, right. Again it prints the value. J value will be incremented by 1. J becomes 2. 2 is less than 2. Condition is failed. The same concept what I've explained. Only the new thing here is we have used a /n and /t. /n, as I said, whenever I'm starting a new row, I have to start with new line. Inside the row, I have to leave. For example, if I want to print 30 and 40, if there is no space between 30 and 40, it will be treated as 3040. So to avoid that problem, after 30, I need a space. That I'm talking about this /t. So we are using /n to start a new line after every row, and /t to leave a space between values in each row. Now we'll write one small sample code, C program, to read and print a matrix of size m into n. Now we'll look at the declaration part first. Declaration, I'm using all the integer values, so I have made it as integer. Row size, column size, I for looping purpose, j for looping purpose, and the two-dimensional array is a 10 10. I have reserved 200 bytes. How much I have to use it? It is left to you again. First line I'm writing here, enter the row size and the column size. Fine. Two values I'm scanning and I'm placing it in yum and n. Yum is filled with row size, n will be filled with column size. Now I'm asking again user to enter the elements. Just now I have used a value for m is 3. For n it is 2 I have used. 3 cross 2 matrix I have used. So m is 3, n is 2. Now we'll consider enter the elements. So it will start from the I equals to 0. I is less than row size, and j loop I'm using for the column purpose. So j is less than n. I'm start reading. The same code, what I've explained there, here also it is same. It reads each time row value changes, column value, 2 values will be filled in each row. Again, row value will be incremented by 1. It again reads 2 values in that row. Again, row value will be incremented by 1. Again, it reads the value. Now, how to print? After reading, the values will be placed in a proper position. How to read the values? How to print the values now? How to print? The elements are Again, I have to start from the beginning, take the value from the beginning until the row size I plus plus. I said whenever I'm printing row values, I have to start with new line. So it will leave the one line, it will move to a next line, then it fills the values. Again, there is a tab space between the values. Just now I explained, right? In a previous slide, I've explained why I'm using this code. So you have to remember one thing: to read a matrix, what all things are required? Row size, column size, one for row values, one for column values, and this is the two-dimensional array. First thing, I have to fill the values of row size and column size. First, I have to read the row size and column size. Then start filling the values. How many rows are there? How many columns are there? You keep on filling the values. This is the way of reading. Now, how to print it? Whenever I have to start from the beginning, how many rows are there? How many columns are there? To start from the beginning. Whenever I'll start a new row, I have to start with new line. That is that thing you have to remember. And in between the values, I have to leave tab space. Right? This code is fixed. Printing code is fixed. There may be, if I want to read another matrix here, then the size of the matrix I can take it as PQ. And name of the array is B of 10, 10. Now first I'll read the first matrix. Fine, I'll read the elements of first matrix. Then I'll ask a user to enter the size of second matrix. Read it as PQ. Then read the elements of second matrix. Everything is same. Where you have M, you have to replace it by P. Where you have N, you have to replace it by Q. Where you have A, you have to replace it by B. Everything, the line, the loops, everything remains same. Only the size of a row has to be changed, size of a column has to be changed, and name of the array has to be changed to read the another matrix. Similarly, to print the matrix B, what changes I have to do? This all will remain same. This all complete thing will remain same. Same code I have to write it again to print the elements of matrix B. What I have to change here in this code? M value has to be changed as P. N value has to be changed as Q. A has to be replaced by P. Rest all is same. So if you want to print two matrix, then first you have to declare size of that matrix, row size, column size, and the two-dimensional array. Then read the size of a matrix, then read the elements of a matrix 1, then read the size of a matrix 2, read the elements of matrix 2, print the elements of matrix 1, print the elements of matrix 2. Clear? I hope you have understood. Now the output, it is asking me enter the row size and the column size. I have entered 2 and 2. 2 will be assigned to M and 2 will be assigned to N. Now enter the elements. I have entered 11, 22, 33, 44. You can enter few more elements, but it will not take those elements. Now the elements are printed in a matrix form. I was talking, see, if I'll not write /n, the values will start printing from here. Values will start printing from here. So what I have to do, I have to start always with the new line. So 11, 22, 33, 44. I'm talking about this /n. I'm talking about this /n. That is, every time I want to start with a new line. Each row must be start with a new line. This /n I have used for that purpose, and I have leaving the space between 11 and 22, 33 and 44. For this purpose, what we are using /t. /t for tab space, /n for new line. Thank you.